Hello. And welcome to another fantastic edition of Phillips Podcast Store. Pete, after watching today's podcast, you should be able to identify and solve for various angles. Today's podcast is going to be on lesson 5.1, classifying angles. Remember, guys, that an acute angle, by definition, is any angle that is less than 90 degrees. Acute angle, any angle that is smaller than 90 degrees. An easy way to remember acute angle: the doctor walked in to the hospital room and said, "Congratulations, Mr. Angle. Congratulations, Mrs. Angle. You are the proud parents of a cute little angle." Acute angles are little. Obtuse angle. An obtuse angle is any angle that is greater than 90 degrees but less than 180 degrees. Some students in the past have said to me, "Mr. Phillips, you can remember an obtuse angle because an obtuse angle is big and it almost looks like the chair that you sit in when you're at the dentist." An obtuse angle, greater than 90 but smaller than 180. Right angle. A right angle, usually identified by a box or square, and a right angle is always 90 degrees. A straight angle. A straight angle would be a straight line, and a straight angle or a straight line always contains 180 degrees. Straight angle, 180. All right, complementary angles. By definition, complementary angles are two angles that add up to 90 degrees. So if you take a look at the example here, this is 30 degrees, this is 60 degrees. If I add those together, that gives me 90 degrees. So I'm just going to type in here, two angles that add up to 90 degrees. It can be any combination of numbers that add up to 90 degrees. So for example, if you had two angles and one of them was, let's say, 75 and the other one was 15, if we add 75 and 15 together, that should give us 90. These would be complementary also. Two numbers, two angles that add up to 90 degrees. Next slide. Supplementary angles. Supplementary angles. By definition, supplementary angles are two angles that add up to 180 degrees. Supplementary angles, two angles that add up to 180 degrees. So in this case, I have an obtuse angle, nice vocabulary word, Mr. Phillips, of 135 degrees, plus 10 for your group. Good job. Acute angle, less than 90. If I add those two together, that gives me 180. So by definition, they are supplementary to each other. Here, you should be able to see that you have a straight angle or straight line. A straight angle or straight line always has 180 degrees. Excellent job. So angle 3 and angle 4 are supplementary to each other because whatever numbers they are, it has to give you a straight line, which is 180 degrees. So I'm just going to hop back to the last slide for a second. Copy and paste, and then change a word here or there. Two angles that add up to 180 degrees. Bada bing, bada boom. Visual people, you should be able to see on the last slide we talked about a straight angle. If I take this straight angle or straight line and put it up here, that has to be 180 degrees. All right, congruent angles. Congruent angles. By definition, congruent angles are two angles that are equal to each other. So this is 60 and this is 60. Since they are both the same number and they are equal to each other, we say they are congruent. If this angle is 120 and the other angle is 120, by definition, they are equal to each other. They are congruent. So I'm going to throw this in here. Angles that are equal to each other. Or you can think of them angles that are the same numbers. Congruent angles. They are equal to each other. Alrighty, vertical angles. Vertical angles. First thing you should notice is that you have intersecting lines. Car crash. Intersecting lines. So I'm going to write up here. Angles that are formed by intersecting lines. So that's the first thing I know about vertical angles. They're angles that are formed by intersecting lines. Next thing I'm going to say this is angle 4 and this is angle 2. Next thing I notice is that they are across from each other. So vertical angles are across from each other. Let's change the color. Angles that are across from each other. All right, so vertical angles are formed by intersecting lines, and they are across from each other. The next thing I'm going to notice are these little markings. This tells me that these two angles are congruent. See how there's 2 marks here and 2 marks here? These two angles are congruent. And let's color code it. And there we go. So angle 2 and angle 4 are formed by intersecting lines. They're across from each other, and they are congruent by definition. Vertical angles. Angles that are congruent. And remember, congruent means equal to each other. Angle 1 and angle 3 are also across from each other. They're across from each other. They're formed by intersecting lines. And angle 1 and angle 3 are also congruent or equal. So let me slide these over, perform a little translation, plus 10 for the bears. And let's just pretend that I told you that angle 4 was equal to, let's say, 50 degrees. You should be able to say, Mr. Phillips, these are intersecting lines. I know that intersecting lines form vertical angles. So Mr. Phillips, angle 2 and angle 4 have to be congruent to each other, the same. Mr. Phillips, if angle 4 is 50 degrees, by definition, this is a vertical angle. It has to be congruent, or it has to be the same, 50 degrees. Now, if I ask you to find angle 1 and angle 3, you should be able to tell me, Mr. Phillips, straight line. Or you can say, Mr. Phillips, straight line. Mr. Phillips, remember from earlier in the podcast that a straight line always has 180 degrees. So, these two values, angle 1 and angle 4, have to make a straight line. They have to equal 180 degrees. Easiest way to solve the problem, Since 50 and some number has to give you 180, just do 180 minus 50, and that gives you 130. So angle 1 would have to be 130 degrees. These two add up to 180, which is a straight line. By definition, you should be able to say, Mr. Phillips, these are intersecting lines. Intersecting lines form vertical angles. Nice vocabulary word. Vertical angles are across from each other, and vertical angles are congruent to each other. So, Mr. Phillips, angle 1 and angle 3 are across from each other. They have to be congruent, equal to each other. So if angle 1 is 130, angle 3 has to be 130 also. Also, another trick you can use on these guys, if I put a circle in here, all four angles will form a complete circle. A circle has a total of, excellent job, plus 10 for your group, 360 degrees. If you add 130 and 130, it gives you 260. 50 and 50 gives you 100. 100 plus 260 gives you 360. It adds up to 360, or a complete circle. Alrighty, let's work some problems. If I ask you to find the value of x, the first thing you should be able to tell me is, Mr. Phillips, this is a straight line. Mr. Phillips, I know that a straight line, straight angle, has 180 degrees. So I'm just going to ignore the part that's over here, and this is all I'm looking at. You told me that a straight line has 180 degrees. Straight angle or supplementary angles add up to 180. So these two put together are going to have to equal 180 degrees. So I'm going to say 7x plus x plus 20 equals 180. Or I'm going to write an equation. So I'm going to say 7x. Here's my 7x plus x plus 20 and remember, guys, they have to equal 180 degrees because it's a straight line, or you can say they're supplementary to each other. All right, now I'm going to do hearts and stars, or combining like terms. Infinite cloner minus 10 bears. There we go. All right, your choice. You can either put the stars together first or the hearts together first. It doesn't matter. It doesn't matter how the Cubs get to the World Series for Mr. Phillips. Just get there. I'm going to put my hearts together first. And plus 10, if you said, Mr. Phillips, you need to put a 1 in front of that x. Excellent job. I'm going to put my hearts together. 7x plus 1x. 7 plus 1 gives me 8. The dog follows me wherever I go. Rewrite my problem. So I have 8x plus 20 equals 180. Hearts and stars. Now I'm going to get my stars together, and I'm going to say 20 is going to come over here. Excellent job. If you said you have to do the inverse of adding 20, why? Because you went across the line. The inverse of adding 20 is subtracting 20. When I subtract them, I get 160. Rewrite your problem. Excellent job. If you said the inverse of multiplication, because they're touching each other, is division. And excellent job if you said we write division with a fraction bar. So I'm going to divide both sides by my coefficient, plus 10 bears of 8. 16 divided by 8 is going to give me 2. Bring down my 0. So in this case, x equals 20 degrees. BRB. Alrighty, next problem. Find the value of x. Well, first thing I'm going to think of, are these angles vertical? Are they complementary? Are they supplementary? Well, I'm thinking vertical angles are formed by intersecting lines. By definition, vertical angles are across from each other, and vertical angles are equal to each other. So, visual peeps, you should be able to see that these angles are across from each other. They're clearly formed by intersecting lines, and vertical angles are equal to each other. So, since they're vertical angles, 75 degrees is going to equal 2x plus 1. Excellent job if you said we're going to write an equation. Plus 10 for your group. Hope you're keeping track of your points because I'm only keeping track of mine. So I'm going to write an equation. 75 degrees equals 2x plus 1. Excellent job. You said use a commutative property, which means you can switch the order around. Plus 10. So I'm going to rewrite it. 2x plus 1 equals 75 degrees. Hearts and stars. Excellent job. Plus 10. Combining like terms. I'm going to put my stars together. When I take the positive 1 across the line, I do the inverse. The inverse of positive 1 is negative 1 or subtracting 1. That's going to give me 74 degrees. Rewrite my problem. The inverse of multiplication is, excellent job, division. Divide both sides by my coefficient of 2. These go to ALC. 74 divided by 2 should give us 37. Check my math. If I'm wrong, let me know, and you'll get a Jolly Rancher. If I'm right, then I get a Jolly Rancher. So I'm going to say x equals 37 degrees. All right, find the value of x. Well, this one should be very easy, guys. Not a whole lot of work to do, if any. I'm thinking I have intersecting lines. Intersecting lines, form vertical angles. Vertical angles are across from each other. Vertical angles are congruent. Nice vocabulary word. Congruent means equal. So in this case, if this is 70 degrees, x has to be 70 degrees. They are congruent or equal to each other. Alrighty. Angles formed by intersecting lines are called vertical angles. Visual people, if that didn't work for you, let me get rid of this. You should be able to see they're across from each other. Angles that are across from each other are vertical or congruent. So if this is 70, x has to be 70. If I change the problem and I said this angle was 61 degrees, then you would be able to tell me, Mr. Phillips, x has to be 61 degrees. They have to be equal. Alrighty, next slide. Find the value of x. I'm going to ask myself, intersecting lines, vertical angles, complementary angles, supplementary angles. Well, I'm thinking that this is a straight angle or a straight line. A straight angle or straight line, or you can say these are supplementary to each other, have to add up to 180. So 85 degrees and some number have to add up to 180. Easiest way to work the problem, say 180 minus 85 degrees. X would be 95 degrees. Plus 10 if you told me, Mr. Phillips, to check your work, add them together. So I'm going to add 95 and 85. If that gives me 180, bada bing, bada boom, I know I'm right. Find the value of x. I'm asking myself, vertical angles, complementary angles, supplementary angles. I remember the crazy math teacher saying something about when you have a box that's 90 degrees, two angles that add up to 90 degrees are complementary to each other. So, since these are complementary angles, they have to add up to 90 degrees. I'm just going to do 90 minus 69, and that gives me an answer of 21. So x has to be 21 degrees. Plus 10, if you said to check your work, add them together. When you add them together, if it gives you 90, bada bing, bada boom, you got it. Tributary joins a river at an angle, so it forms an angle here. Find the value of x. So I'm going to look at the picture and I'm going to say, do I have vertical angles, intersecting lines, complementary angles, supplementary angles? Well, I'm thinking this is like a straight angle. And if I bring this line segment up here, now I have supplementary angles, or one big straight angle, and by definition, I remember that a straight angle or supplementary angles have to add up to 180. Easiest way to work the problem, I'm going to do 180 minus 127. When I do that, bada bing, bada boom, I get 53 degrees. Check your answer. 127 plus 53 gives you 180. Bada bing, bada boom. Find the value of x. Ask yourself, complementary angles, supplementary angles, vertical angles. Ooh, excellent job. Plus 10 if you said vertical angles. By definition, vertical angles are formed by intersecting lines. They are across from each other, and they are congruent. They definitely are across from each other. I have intersecting lines, and they are congruent. So, easy pleasy. Kind of like as easy as the Cubs make it to lose. If this is 128, this has to be 128. If I asked you to find the other two angles, out of curiosity, you have a couple choices. You could say, Mr. Phillips, I'm going to use the 128 here or the 128 here. It doesn't matter. You could say, Mr. Phillips, straight angle, straight line, so it has to give me 180. So 128 and some number has to give me 180. Easiest way to figure that out, do 180, excuse me, minus 10 bears. 180 minus 128. Mental math, Mr. Phillips, 180 minus 130 would be 50. Add 2 more, so that should give me 52. So this would be 52 degrees. By definition, they are across from each other. They are congruent. If this is 52, this is 52. If I'm wrong, please let me know, and I'll give you a Jolly Rancher. If you tell me I'm wrong, and I'm really right, and you're wrong, then I'll eat your Jolly Rancher. How's that sound? Sounds like a plan to me. Find the value of x. I'm thinking right angle, 90 degrees. These are complementary to each other. So I'm going to write an equation. Ooh, misspelling there. Minus 10 bears. Plus 10 for your group. There we go. Much better. It's a good thing I found it before you found it. Otherwise, I would have had to give you a Jolly Rancher. I'm going to write an equation. These two have to add up to 90 degrees. So I'm going to say 4x and plus 2x An equation always has to have an equal sign. Good job, plus 10 for your group. And since this is 90 degrees, these two, when you add them together, have to equal 90 degrees. Hearts and stars, combine like terms. If I do it right, I should get 15. Let's see. Heart, heart, star. I'm going to add my coefficients together. Excellent vocabulary word, Mr. Phillips. So I'm going to add 4 and 2 together, which gives me 6. Woof, woof. Dog follows you wherever you go. 6x equals 90 degrees. The inverse of multiplication. Good job. Divide both sides by your coefficient. Good job, ALC. 90 divided by 6 should give me 15. So x equals 15 degrees. All right, almost done. I promise, because I want to watch the Bulls tonight because they're in the playoffs. Find the value of x. I'm thinking this is a straight angle, straight line, or you can say they're supplementary to each other. Easiest way to solve the problem, since they have to both give you a total of 180, why don't you do 180 minus 123? We do 180 minus 123, and that gives you 57 degrees. Easiest way to check your answer, add 57 and 123, see if you get 180. All right, quick review of discrete or continuous domains. Remember, if you want to know if it's discrete or continuous, look at your domain or your x value. Ask yourself, can I break down hours? Yes, you can. You can break hours down into minutes. You can break hours down into seconds. You can break it into milliseconds. So since I can break down hours into a smaller unit, anything that can be broken down into a smaller unit is, excellent job, continuous. And I believe there's one more. I want to know if this is discrete or continuous. Remember, look at your domain, your x value. Ask yourself, can you break stamps into smaller pieces? Well, you may say that you can break stamps into smaller pieces, but if you do, please don't give them to me, because then when I put my Mother's Day card in the mail, it's not going to get there, because if you break stamps into smaller pieces, the post office won't deliver it. So since you technically shouldn't break stamps into smaller pieces, because then your mail will be undeliverable and it'll come back to you, it can't be broken into smaller pieces. It would be discrete. Discrete can't break down into smaller pieces. Continuous can break down into smaller pieces. Remember, always look at your domain or your x. Ask yourself, can my domain or my x be broken down into smaller pieces? Alrighty, I told you we would be done so I can go home and watch Chicago Bulls. Hopefully they'll win tonight. Thanks for watching today's podcast. Stay tuned for our next podcast on lesson 5.2, similar triangles. See ya. Wouldn't want to be ya.